Okay. So,
Okay.
uh, so first step we follow is the descriptive analytics, right? So what is the purpose of the descriptive analytics? Once you have the raw data you have in hand, you want to understand the nature and the characteristics of the data, right? It could be inferential statistics, right? It could be some kind of the sample selection, some kind of hypothesis testing. The purpose is what happened, right, in your raw data. So under the descriptive statistics, we typically do like your uh, central tendency. We do a data dispersion, right, like the deviation range. We do the data shape and data location, right, like kurtosis, right, skewness. All this we do under the descriptive statistics, right? So the basic goal of the descriptive statistic to understand the characteristics and the nature of the data. Then moving up, we have something called diagnostic analytics. Under the diagnostic analytics, once we have this input data, input you also known as the features or also known as variables, also known as parameters, right? So once we have this input data, right, we wanted to do a root cause analysis in order to figure it out or in order to identify which of the variables contributes maximum to your output variables, right? Suppose I'm doing a prediction how your the students will perform in the year 2025. So there are various parameters in terms of uh, the attendance, in terms of their score in mathematics, physics, right? So I wanted to see out of these various parameters, which parameters contributes maximum to your output, like the performance, right? So this we do typically the root cause analysis. We can do the feature selection. It is also known as the feature engineering, right? So that is the purpose of the diagnostic analytics. Then moving up, see, once we moving up, the value also we are creating more value for our raw data. Then we have the predictive analytics. The predictive analytics is once the prediction is involved, one it involves the forecasting, right? What will happen? So that typically we do the tasks for the predictive analytics like regression. We do the tasks like classification. We do the tasks like time series analysis. So these are the like we can do a deep learning, we can do a reinforcement learning, right? The AI, right? But the purpose is the predictive analytics. So you wanted to forecast the raw data, right? What would what would be, right? The future, right, of the raw data. So this will be the predictive analytics. Then moving out, we have something called prescriptive analytics. How can we make it happen? This is also known as your expert system, a recommended system, right? Suppose we predict something, let's assume like we predict something like uh, our sales figure is not doing very well for the next year 2025, right? So what we are projecting and what we are predicting, it is not in line with, right? So immediately we look back to our raw data in order to figure it out that in the diagnostic analytics what the typically like the weight or the rank we have got from the input parameters. So on the basis of the weak parameters, we can recommend something to prevent or control these mishappening to happen, right? Unwanted things to happen. So that is known as the prescriptive analytics. So these four type of the analytics broadly we perform. under, like, I will do any kind of the project for the data related project. It could be a data science, data mining, machine learning, artificial intelligence, so and so. How the Statistica support to that, right? Why? Like, because these are more into the theoretical part or more into this thing. So how does the Statistica related to all these things? How the Statistica can help and enhance your productivity for all these concepts or the technology we are talking about. What the Statistica brings to you. You can view my screen.
Yes, sir.
Okay, what the Statistica brings to you, the software you have bought, Statistica as a product, right? It is a very old product. It is there since 1984 in the global market, right? So, right, it's around 4 decades from now, the Statistica available in the global market in India also. What the Statistica brings into 16,000 functionality or 16,000 features. So what we saw in this component of the data science, databases, data processing, visualization, statistics, machine learning, artificial intelligence, right? So all the algorithms will be available in Statistica. And as a product, Statistica falls into the category of the no coding, low coding tool. No coding, low coding tool means even in to perform a basic statistics or the descriptive statistics to the very, very high and algorithm like your machine learning or maybe AI, artificial intelligence, you need not to write a single line of the code because you are the code technology expert. You are not a computer science or IT background, but still you will be dealing with all these algorithms because these are the algorithms. You go to the research paper, you go to anywhere because there is a tremendous amount of innovation or the researcher happening using all these advanced algorithms, right? But your domain expert are the code technology, right? So you are not a coder, right? So you would hesitate to write, right? Or you'll be afraid to write 100 lines of the code to perform something. So here a tool like Statistica, it's a no coding and low coding the tool, right? So you need not to write single line of the code in order to achieve your innovation or objective. Open standards like the Statistica, in addition to this low coding, this thing, the Statistica is a very, very like open in standards. What does it mean? Within the Statistica also, suppose those who wanted to do some kind of the customization automation, they can write the code in Visual Basic. And since the Visual Basic was a classroom subject in the class 6, 7, 8, many of the people, they are conversant with the Visual Basic. So for any kind of the tasks of the customization and automation, you can write the Visual Basic, and Statistica also support the various open source. Because now a couple of software, they are very, very popular in this domain of statistics, advanced analytics, data analytics like R, Python, Spark Scala. So these are the very, very popular open source, like under the mm, general licensing policy, right? So Statistica also support all the open source to write the coding. Then we have something like the process monitoring quality control. In addition to the conventional statistics, data mining, data science, Statistica also provides the feature for industrial statistics, Six Sigma, lean manufacturing. These are the also features. Suppose many of the scholars, they may have the aspiration to go to the industry also for employment. right? So they will get a hands-on like the concept like your quality engineering, process analysis, Six Sigma. If they have an interest, the Statistica provides the features and the capability to support that area also, like the process monitoring, quality control. It's a very expensive user base. Like for your information, over 20 CSIR lab across India they have been using Statistica for years now, starting from your NAL, National Aeronautics Laboratory, to the NIO, National Institute of Oceanography, because now currently data is everywhere, right? Maybe the domain can be different, but data is everywhere. So once you have the data, you can apply the analytics in order to uh, get insights or information or knowledge or wisdom from your raw data. So that is the reason, right? So irrespective of, because CSIR lab, these are the specialized lab for specific domain, but data is independent of the domain. So that is the reason, starting from your aeronautics laboratory to the oceanography, to the Central Drugs Research, to the Indian Toxicology Research, right? So they have been to the NML, National Meteorology Laboratory, to the your ICMRE, because these are the domain for manufacturing. So they have been using those who deals with the data. You have to use this kind of the advanced technology in order to get the insights from the data. So this is the part of like the overall view of the data, to know what you have invested, why you have invested for a tool like Statistica. You can open your mic if you have any queries, so we can have the 2-minute query session. Then we can move into the real time or the live for the Statistica application. Over to CFTRI. You can open your mic if you have any queries in mind. Hello?
Yeah. Hello, sir.
Yeah.
Yes, sir. No questions. Sir, we can go ahead. We don't have any questions.
Okay, wonderful.
We'll ask. Maybe at a later stage we'll ask, sir.
Okay, I would urge and pursue, like suppose in the side by side, you can also open the Statistica, any of the researcher or any of the participants. That will be great. So you can do also the same thing along with the practical session. So that will help to receive more rather this thing. If the situation are permissible for such kind of thing. Else, I'm moving with the Statistica. I'm opening the Statistica now. You can view the screen.
Yes, sir.
Okay, so this is the first, once I launch the software Statistica, this is the first interface of the Statistica. This may slightly different depending on your setting during the installation, right? But this is what typically.
इनका इनका ही दिखा दीजिए इनका ही खुल दिखा जी ये ऑलरेडी है ना इसका
right? So this is the Statistica we have, and what you see now, this is the graphical user interface.
देखना दीजिए ये हो रहा है ना उसको ही करने दो ना उसको ही करने दो ये
Hello? Yeah, so this is the graphical user interface, the first interface, which is known as the ribbon bar, right? Just typical look and like your Microsoft Excel, right? So if anyone is conversant with the Microsoft Excel application, they can use the Statistica, the specialized application, without doing more learning, right? So that is more into the inspiration from Microsoft. You follow my pointer. If I click here, use classic menu. If I click here, my interface will change to a typical drop-down menu, right? I have this drop-down menu. If I click the file, I will get all the features for the data import or data acquisition. I can create a new file, I can open a new file, I can open examples, so on and so forth, right? So this is another type of interface in Statistica called classic menu. The operation, the features will remain same, only it is the interface, right? So it does not make any difference. So depending on your comfort, right? And in the below, you can see Cycle Limited, Operational Excellence, Dr. Reddy Lab, Operational Excellence, Stability Calculator, Aspire DMAC, right? So these are the basically an outcome of the customization or the development using Statistica Visual Basic. Suppose you have also some SOP, right? Standard operating procedures, or once the researcher get into the lab, there are certain like the data testing or something they wanted to do, right? So they can do this kind of the customization, right? For like basic statistic, normality test, and all this customization they can do, and they can embed these uh, tab like the CSIR-I, CFTRI, the lab name, and all these things, right? So if you wanted to change the interface, you go to the view, you go to the ribbon bar, the interface will change from classic menu to ribbon bar. In addition to these two type of interface, we have another interface, what we say, the workspace. You see, workspace, right? So this is basically like a white canvas kind of thing. Suppose you wanted to undertake any projects in data mining or any kind of the projects you wanted to undertake, right? So you can use this canvas or you can use this whiteboard. What is the advantage? So more into a visual workflow, right? That drag and drop, visually applicable, and whatever the step you have performed, all the steps are visible here, right? So it's, and suppose you wanted to do the same repetitive task, you need not to do the repetition again and again. If you create the workflow, it is just like a Microsoft Word template, right? So you have created the template, you have created the workflow once, right? Just in the next time, you just wanted to plug the data and rest of the things will perform automatically, but not automatically. You have got all the control, right? These are the connection. You have the control. You wanted to run it. You wanted to deactivate. And you see the wheel kind of the things there. You can do all the parameter setting, right? So here, this we are developing a credit scoring model, right? So here we are splitting the data into the training and testing. We are doing a random sampling here. Then we are applying, because this is a classification prediction problem, we have been applying couple of algorithms from decision tree or decision science like classification, regression tree, boosted classification, random forest. Then we are getting the PMML. We are doing the cross tabulation for the evaluation. Then we are getting this thing, right? So what is the message for you? So once you advance to from your ribbon bar in the classic menu, and you have become from a beginner to an advanced user of Statistica, uh, you can use this workspace to avoid the tasks of the repetition, and to use this workspace, you can reuse this workspace again and again. You need not to carry out all the analysis again and again for a specific objective. So what is the message for you? The message for you, the Statistica is a no coding, low coding, graphical user interface tool, right? and it provides you the three interface ribbon bar that is mostly or commonly used by the user, ribbon bar for the Excel. Then we have another type of interface is the classic menu. Then we have another type of interface is the workspace. Fine. In addition to that, what I was talking about, the Statistica also gives you uh, the features for the open source integration. If I am conversant with the R or I am conversant with the like see, you have this R node, right? So you can write, you can integrate, or because the Statistica, the integration is there, so you can run the R code. If you are conversant with the C sharp, you can write the C sharp language within the Statistica, this kind of this environment. If you are conversant with the Python, you can write the Python code within the Statistica interface. Even you can write all the code in one go. You can use the Statistica, you can use the R code, you can use the Python code, depending on your choice, depending on your comfort. There is not a big, like, as I was talking, like the Statistica is a very, very open tool, right? So we embrace all the native technology or the similar kind of the technology which can add value to the user or to the researcher. Fine. So I am closing this. Fine. So this is in terms of the interface. And whenever you are dealing with the Statistica, there are enough resources, electronic resources are available which will help the beginner or the user of the Statistica to, to support as a guided analytics, right? So here you see we have something called help and support. If you expand this help and support, the help, if I expand the help and support, right, 100 of the examples are listed here. You see, 100 of the examples are listed here. Basic statistics, right? How to perform a descriptive statistics, t-test, correlation, breakdown, and one-way ANOVA, frequency tables, sub-containers, right? And all if I will open, all the data sets, the example data sets are inbuilt within Statistica, right? Here, this example is based on study.star. Data file is included in Statistica. The data contains, it gives you the variable description also. The data file contains 25 variables and 50 cases. These fictitious data were collected. So you can go through and you can do as a follow-up practice, or you can say the self-paced learning. You can learn in your self-defined time and this thing, right? So let's get started, right? So first thing, whenever we have the raw data, right? So primarily we receive the data in the two forms. One is primary data, one is secondary data. The primary data is what we once we create or input the raw data, right? So as I said, because different tabs has been defined for the specific functionality or specific tasks. For all the file related activities, right? It has been, you can get it from the file tab. If I explain the file tab, if I wanted to create a primary data, I can go to the new file, new. I wanted to create a spreadsheet, right? As I was talking, the statistic of all the operation you do, it is interactive and intuitive. So you can interact with these dialog boxes to define your specification. Let's assume I wanted to create number of variables, put the 100. Means number of variable denotes to your column, right? Number of cases, let's put 10,000, right? Case name length, right? That you can define. Suppose there Statistica support four type of the data: double, text, integer, and byte, right? Double is the more universal. It accommodates both your continuous numerical the variable. So that is the reason by default it has been displayed. The variable length is straight. There is a display format, how this display of the variables will be there. So there are certain like the inbuilt libraries are there. So you can define to that, right? Let's go with this specification. We wanted to create a new new spreadsheet, which consists of, based on my specification, 100 variables, number of cases 10,000. If I click here, one spreadsheet will be created. You see 100 variables, 1,000, 10,000 cases. The volume of the spreadsheet always display on the top of here, right? So very well you can figure it out. What is the, suppose I wanted to do some kind of the changes here. I go to the variable, I double click. I wanted to create a variable called, let's assume the gender. Gender. I wanted to do a very quick and the fast data input. I go to the text level. I wanted to decode this. The text level, I'm decoding this male to 1, female to 2, and others to 3. Okay? Because many of the occasion, like you wanted to convert your text variable to the numerical variables, this is the way you can decode. Okay. I put like 1, 2, 3, right? So that is the way I can do this very uh, quick data entry. I can expand it, right? And suppose some kind of the addition, modification, alteration to this new spreadsheet, I can put anywhere. Like suppose I wanted to change some variables, I right click. So there will be a shortcut menu available there, right? If I would like to add variable, how many? One. After that, assume after one, I would like to add two variables, like all this stuff you can do, right? So suppose I wanted to deal with the cases, right? I can go to the add cases, copy cases, delete cases, move cases, case name management, right? So all this, the flexible option I can get from this, right? But that is not the thing we have been doing, because today we do not deal with this primary data. Largely, or most of the time, we deal with the secondary data. Secondary data means the data is available somewhere, some source, and we wanted to import into the Statistica to carry out the analysis. So how to do that? I can go here, file. I go for this open file, right? As I said, for the different tab, the specific tabs are there. The file tab is meant for all the data acquisition activities. I can go to the open file. right? So what you see here, these are the files formats are supported by the Statistica, right? Couple of the file formats we'll be dealing with, like Excel, it could be Excel, it could be text or CSV, right? So, or it could be the similar kind of the software, or it could be like other software, right? So you need not to worry much about, because you may have in CFTRI, there are many of the other softwares also there, the similar kind of the software. Suppose you get the raw data, so you can deal with the Statistica, because Statistica support broadly around 165 file formats, right? So let's deal with one of the data set, how I can bring one of the Excel data set into the Statistica, right? I go to this, I go to the open example, please mind it. I go to the open because Statistica, as I said, there are multiple resources are available for your self-paced learning or self-paced practicing. So if you wanted to do some kind of the follow-up practice or some practices, 100 of the example data sets are available in Statistica. So I will be dealing with all these example data set file data set, which will be useful for you to carry out the analysis. I go to the open. I go to the went to the open example. Open example. I went to the data sets because these data sets are available within the Statistica, right? So my current task is I wanted to bring a data file, or I wanted to import a data file which are available in Excel. So I went there, I defined the format, Excel file, XLS. So there are a couple of, or there are many files which are there within the Statistica example. So I will be dealing with a file called piston 2. I went to the piston 2. Okay. Again, as I defined from the beginning, Statistica, all the operations are interactive and intuitive. So you can interact with various dialogue to define your own specification or own uh, requirement. So here I have got three options: import all sheets to a workbook, import selected sheets to a workbook, open as an Excel workbook, right? So let's like go to the open all sheets to a workbook, because we are aware because this is only one sheets are there, right? So here again, I got this, asks me about formatting, get variables names from the first row, get cases from the first column, import cell formatting, don't create. Let's go with the default specification, but Statistica by default, it help and support, right, to get the optimum specification for the specific analysis. So let's go along with this, get variable names from first row. So I got the Excel data into the Statistica, but what I can see here, the structure of the data is not very well formatted, right? So again, I need to do some kind of the manual intervention to make the data ready for analysis, right? I need to relate with this fine. So how I can overcome for such type of the challenges? Again, I go to the open example. I'll be dealing with the same data set. I was dealing with the Excel. In dealing with the Excel, I was dealing with a data set called piston, import all states. Now what I will do, because I saw there is some kind of the changes are needed in the structure. So now I will be doing ask me about formatting. I click here. I would recommend whenever you will be doing the practicing, you can do all the permutation and combination to have a better understanding. So I click here. Now I see on a working. Okay. I will change this. Let's do get variables from the first row. Okay. An example data set. Excel table system. Open. Okay. Yeah. So now it's looks better, right? So I get again, I can do some kind of, so in one click, I can define any of the specification, right, to make the data more structured, right? And I can do so. But let's do, because we deal with the Excel data, right? If I do have the data set in the semi-structure like CSV or .txt, right? So how to deal with that? So again, I go to the, I will, hello?
Hello, sir.
Can you hear me, sir?
Yes, sir.
Okay, my voice is clear because my Bluetooth got discharged. So my voice is clear now. If I do in this also, you are hearing properly?
Yes, sir.
Okay, wonderful. Thank you. So let me do bring some kind of the semi-structured file like txt or the this thing. So how to do that? Again, I go to the open example, go to the data set, open. Now I have to deal with the txt or the CSV, right? So couple of files are there of the txt and the CSV. So we'll be dealing with one of the data set called credit scoring, right? Okay. So the Statistica automatically sends the delimiters here. The delimiters are the tab, space, comma, semicolon, right? So, and I can view the file because Statistica automatically senses and like Statistica intelligently senses these file consist, the delimiter consists of the tab. I can preview, you see in the below, whenever you are bringing the text or the CSV file, put the auto refresh so you can preview the structure of the data like that. Fine. So I'm good with this. I'm good with this kind of the selection, right? And I can go ahead. and I could bring my data from CSV or text file into the Statistica. In addition to that, like let's assume, suppose I do have a little more complex data set, right? Okay, multiple. You see, can you view one of the data in the notepad? Name, weight, age, weight. Can you view the data? Hello.
Yes, sir, we can view it.
Okay, so this is a slightly a little more complex compared to what we deal in the past, the semi-structured data, TXT or this thing. So let deal with this data, how in a point click, we can bring this data into the Statistica. I went there, the process will remain same. Go to the open documents. Right, I'm dealing with one of the CSV file, but currently my source is in the desktop. I stored this file, multiple delimiter sample. Okay. Okay. I can preview my data here because this is slightly a little more complex CSV data. By default, it has taken the comma, right, intelligently, but this is not going to work out for these kind of the complex semi-structured data. We have the Statistica offers a flexible option called others. So where you can define the multiple delimiters in order to import the data. So you can do here, right? So you can apply another delimiters, right? You can apply another. It's getting better and better now. You can apply another delimiters. Okay, this looks good, right? So I applied the multiple delimiters. Since I have checkbox, the auto refresh, I can preview my data structure. Let's go with this. Now I got my data in a very structured format. Now it is ready for analysis. Fine. So this is the way you can bring your data from the various format. In addition to that, if you have the databases, your data could be in Microsoft SQL, your data could be in Oracle, your data could be in Teradata. Still, it can be deal with the Statistica through the graphical user interface. You need not to be an expert right? Or to deal with the external databases, right? So let's give you an example. External data, go to the create. I do not have an environment. I cannot show you the practically, but that will give you a sense of how you can uh, yeah, right? So here you can see I have one data set like the for this thing, the cat one, right? Here you see new OLEDB. This new OLEDB OLE stands for object linking and embedding. This is an extension of the ODBC. What does it mean to you, right? If any databases which are compliant to the OLEDB, most of the databases, the standard databases like Oracle, SQL, they are compliant to the OLEDB. So any of the databases which are compliant to the OLEDB, right? So that you can bring into the Statistica rows and column from the databases in just point click. You need not to be a database administrator or database expert in order to deal with the right. So let's go with this. I got this table, so I can bring here, right? So I can get this. I can preview my data on the basis of my selection, right? So this is the way. Even the Statistica creates the SQL statement also, right? What you do in the graphical user interface, point and click, the simultaneously the SQL statement also are created, right? Even suppose you are good in databases, you're good in SQL, you can switch mode. You can, let's say, copy. I'm just doing because I'm not an SQL expert. Switch mode. You get this selection. You can go ahead with this query and it will bring the data, right? So this is the way you can deal with your external databases, and Statistica provides you the advanced feature like this. In addition to that, Statistica provides you very, very high advanced data acquisition features called in the same ETL, extract, transform, and load. Suppose in case you have multiple data files, right? Maybe the 5, 10, 15, right? So I could have shown you, but in best interest of the time, right? When it will take some time, right? So, but I will tell you like how you can practice yourself to get acquaintance with these such kind of the advanced feature, your extract, transform, and load, right? So here, what you can do, as I described in the beginning, to get a sense of any of the features which are available in Statistica, to get an understanding, what you can go to File, go to the Help and Support. Currently, I have an interest in ETL. So I go to the Statistica example. I have to go to my current subject of interest is the ETL. Here you see the ETL, extract, transform, and load. If I expand the ETL, there are 3 example has been listed. Aligning data from a cyclone furnace, comparing historical stock prices, aligning multiple. Let's just for a quick view, we go expand this data set example, aligning data from a cyclone furnace. This example based on a typical application, Statistica extract, transform, and load. Here, they are dealing with the 5. Let me just get you a sense to how quickly you can do that. I go to open example. So currently I'm dealing with a situation where suppose you have the two files, right? Suppose you have the two files. I'm taking only the 3. It could be 30, it could be 5, anything, like, so it's not a big deal for Statistica. By using this advanced feature of the ETL, you can bring the data of your interest. I'm taking 3, the reason because for the 2 data files, suppose I would have the cyclone 1 and cyclone 2, we have a feature in the data called March. Here is the March, right? Under the March, you can deal with the 2 different data file, right? More than 2, right? We have an advanced feature called ETL. So I am taking the 3 data file, right, to perform these ETL. I go to the file. I go to the external data. I go to the ETL because that is a time index process data. And you see, just let me. See, here you see the structure of the data or the nature of the data. The cyclone 1 that consists of this posing, right? But the data, you see the date and time, the data has been recorded in the every 6 minutes. 6 minutes, right? Let's assume, like, suppose I wanted to draw a time. I wanted to see the coal flow, the trend. I cannot draw a time, your line graph to get a sense of the trend using the 1,000 data points, right? Or if I wanted to compare the coal flow of the cyclone 1, cyclone 2, cyclone 3, different, the 3 factory, I have data. I cannot create a line graph or the trend graph for the 1,000 data points. These data points are 1,000 here, right? So I wanted to do some kind of data aggregation. So how to deal with this kind of the scenario? You go to the ETL, you go to your add data source, you go to the documents. Since I have the 3 data file, right? The 3 data file has been listed, but not necessarily like you need to choose it on a sequence or you need to choose all the 3, right? If you click here, any of the data, it could be 3, it could be 10, right? All the data file has been selected. You can bring these data, right? If I deal with this, Then I observe in the data, because this data has been recorded in the 6 minutes interval, right? Okay, right. So I go to the I go to the variable as usual. I will be choosing only, like, let's go with the cyclone 3. This is the data highlighted. I choose only the date and time and cold flow from the data file 3. Only 2. That is my variable of interest. Okay. Then I go to the cyclone 2. I choose the variable date and time and primary, right? In the cyclone 3, I chosen the date and time. You can choose the randomly, sequentially, there is no problem. Just you can pick up the data of your interest. I'm choosing the variable 4 for the cyclone 1. Here you see, by default, this minutes has been converted into the hours. But here my objective is like, or you can do one thing. Only I choose this thing variable. I here also I choose the cool flow because I wanted to do it the trend analysis here. Okay. And variable also I choose the variable cool flow. Right. Cyclone 3 also I choose the variable date and cool flow. Okay. Here I have the option whether I wanted to convert to hours. No, the hours is not going to work out because since the data also will be more, right? I convert into the days, right? Then I go to the advanced. It has been converted. Like again, I get the variety of the option. Either I wanted to like the weekly start from on the basis of the my time recording. I can do that, right? If I go to the variable specification, I can aggregate the data on the variety of the statistics like mean, median, sum, and all this stuff I can do, right? Let's go with this selection. So now my 1,000 data points which had in the interval of your 6 minutes interval. Now it has been converted into the day. Now, and on the basis of the chosen, I choose the mean, right? So suppose let's draw a line graph. Right. So I can draw a line graph in order to see all the my 3 plants, the cold flow. Right. So, but it would be very, very like difficult. Suppose I would like to draw a line graph or the train graph. So here, what I can see, the cold flow, the cyclone, the plant 2, it has got the more consistent in this cold flow. I can see the cold flow for the cyclone 2, the 2-number plant, it has got a lot of variation. I can see the time. Suppose I wanted to see the time and I wanted to do a little more this thing. Can go to this, right? So, and again, the message for you, the Statistica provides you a variety of the 2D graphs, 3D graphs, icon plots, so and so forth. And you have all the control over these graphs. You click here any point of time, right? And you can do any kind of the changes, modification, beautification, anything you would like to do, you can do because all these, the Statistica treats as an object, right? If you wanted to give some name here, right, say, right? So likewise, you can do all these changes you wanted to do in a graph, right? So this is a very, very advanced feature of Statistica ETL, right? It's primarily known as a business intelligence and data warehouse tool, but the Statistica provides you that whenever you deal with the multiple data files, 5, 10, right? Maybe one in Excel, maybe one in CSV, maybe one in text, right? And out of these, what we saw, we had number of variables are large. You wanted to deal with your variable of interest. You can use the ETL features in order to deal with the multiple files. And there is no limitation as such, right? It could be 10, it could be 20. For one file, the simple operation. For the more than one files, for up to 2 files, you can use the feature merge to combine the 2 files on the basis of your interest. And this merge features also includes some kind of the SQL statement, right? So this is the part of your data acquisition. Any queries from this data acquisition part and the interface part? Other side in the CFTRI, any queries from these part, the data acquisition or data import?
Yes, sir. Thank you very much. Our most of the data are numeric, not alphanumeric, and we want to learn from you using the same data how to do the neural network and then PCA, then related to the probability statistics, the RSM means CCRD, DOE, design of experiments, and data visualization. All these things are. I hope
Yeah,
you teach us.
we'll be
studio
progressing
notes.
this. Yeah, no problem. The Statistica could be alphanumeric because the Statistica support the 4 type of the data types. What we saw during the creation of the data, it could be your integer, it could be text, it could be byte, it could be double. So there is no problem with Statistica you can deal with. But once we gradually progress, you see the structure of the data for the various analysis, like you asked for the graphs or for the DOE, right? What kind of the data required. So we'll be dealing with that, right? So let's get started.
Sir, I'm audible.
Yeah, I can hear you, please.
Sir, what happens? We are basically a food lab. So our data is very limited. We do experiments. Okay. So this software, the major use is for design of experiment RSM. So we are also using Minitab because our data points will be hardly 10, 20, maximum 100 data points. All are numeric. So what we expect is this software will give us an equation between the input and output variables, as well as what I found in this software. It is also having ANN modeling. So that is additional to Minitab. So if you can focus more on that, because we get a lot of limited data because we have to do very laborious experiments here. So how to analyze the data, all will be numeric. So if you can,
okay, we'll be getting into
that.
we'll be getting even we'll go beyond that. I do not know how you have been doing with the Minitab, right? But the Statistica provides you the feature of design of experiment, right? In addition to that, Statistica also gives you the feature for this optimization. I will be giving you one example, right?
If you can show us some example, some numeric data, how suppose I have some data input, there are suppose some variables, there is an output. How using RSM as well as ANN, I can get an equation between Y and X variables.
No, that I will show
We
you.
are only using RSM
No, that is so. Before getting into the RSM, either you do the design of experiment. What
Yes,
the
sir.
design of experiment?
Design of experiment, we are aware in Minitab. we are doing response surface modeling also in Minitab. But in response surface modeling, it truncates to second order functions. So that's why we'll be interested in ANN modeling. ANN modeling.
Yeah, DNO experiment also okay. If possible, you kindly show us with some examples how to do it on this in Statistica, because here onwards we will be using on Statistica only.
Sir, during lunchtime we'll send you a data which we have applied through Minitab. It is hardly a 10-point data, and it is using experiments, because one experiment takes 7 days, because you have to do a lot of food analysis. Food analysis takes a lot of time. So that will be, if you can help us to understand, because we don't have much data.
Okay, fine. So let's get into the first half we complete. Second half will focus only on these equation and the optimization. I will show you one example using both the method, because see, in the design of experiment, what typically you do a multiple regression, or you use the simplest algorithm in the backend which does the calculation, right? Either you use Minitab or either use Statistica, any software you do, in the backend it uses a simplex algorithm to do the optimization. I will show you, then we can correlate. So before getting into that, let's do some kind of the basic thing in the first half. In the second half, we will be moving towards your the advanced topic like design of experiment and multiple regression. Fine.
Yes, sir. Yes. Yes, sir. Yes, sir.
So let me pull a data called, as you've been talking, like the data should consist of the numeric and this thing. I'm pulling a data called from data set called characteristics dot star. See the data set, you can view my screen, right? Hello.
Yes, sir. Yes, sir.
Yes, sir.
We are following,
Yeah.
sir.
Yeah,
Yes,
you can view my screen. The data set consists of 12 V means variable. These are consist of, you see, the height consists of the continuous variable. The hair color consists of your categorical variable, or what you say, the alphanumeric variable, right? So this is the type of the variable we have, right? Just perform a basic statistics in order to get a sense of the data, how the Statistica operates, right? Go to the statistics, go to the basic statistics. Under the basic statistics, we have the descriptive statistics, correlation metric, t-test independent by groups, t-test independent by variable, t-test dependent samples. So variety of the hypothesis testing includes the t-test and the ANOVA. But currently I do have something called descriptive statistics. I go to the descriptive statistics. As usual, I will choose the variable of my interest. I choose the variable called height, right? Here, I can choose any of the variables, right? So there are multiple ways, right? If I put this is for, what's it? I can put for, say, right? So this is the way also I can randomly choose. I can sequentially choose, right? Only I need to, right? So this is the way I can choose, but currently in best interest of the time, I will be choosing a variable called height, right? I'll perform a descriptive statistics, but my objective here, I wanted to do a data normality check here, right? I'm dealing with the variable called height. Okay. Whenever you deal with the Statistica comes anything you do, starting from basic statistics to multiple regression or DOE, you need to deal with the 3 tab. Quick, that gives you the very basic output. Then we have advanced, right? That expand your advanced to the white feature. Then we have something called the graphs. So all your numerical analysis will be complemented with the graph. So let's go with the quick. I'm dealing with in the quick tab, I get number of observation 100, mean, minimum, maximum, standard deviation. This is the basic output I get. Then we have something called advanced. This will remain common across the operation of the Statistica, right? Quick tab, advanced tab, and the graph tab, right? So these are the advanced statistics I get, like the sum, median, skewness. If I select the all stat, let's see what would be the output. This is the output I get. You name the statistics, I have it. As I said, it is complemented with the graph also. If I click the G1, I get this output, right? So I get all the numerical indices. I get a histogram. I get a probability plot. I get a box and whisker plot, right? Can you tell me like whether the data, the variable called height follows a normal distribution or not?
Yes. Normal.
Yes, sir.
Yes, sir.
Normal distribution?
Yes, sir.
How do you say that?
No, it is not right side, it is not coming to the ear. So it is not uniform. Symmetry अगर है तो दोनों तरफ it is normal distribution. If the symmetry is there, sir.
अच्छा, ये आप हिस्टोग्राम को लेके बोल रहे हैं, सिमेट्री है इसीलिए नॉर्मल डिस्ट्रीब्यूशन है.
Yes, बोलो. Yes, बोलो.
But because we do not have a statistical evidence, right? Whatever we are interpreting the result, that is out of my experience, right? Do we have a statistical evidence to suggest that जो आप मेरे को normal बोल रहे हैं कि नहीं ये इसी के लिए मैं normal बोल रहा हूँ. आप जो भी बोल रहे हैं मेरे को आप एक एक्सपीरियंस के हिसाब से बोल रहे हो और ये स्ट्रक्चर को, बट ये ग्राफ्स और ये आपका स्टैटिस्टिकल इंडाइसेस को लेके बोल रहे हो. Do you have any statistical evidence to suggest that the data follows a normal distribution? So how the Statistica does that? And this is one of the very like the fundamental assumption we have to qualify. Either I use Minitab, either I use Statistica, either I use JMP, right? My data has to follow a normal distribution, right? So I need to do a data normality check before I carry out any analysis. So how I explore the data through visually, I go to graph, I go to histogram. I was dealing with the variable called height. Okay. Have you heard of this kind of the test set? Sapir-Whorf test, Anderson-Darling test, Kolmogorov-Smirnov test?
We have heard.
Have you applied that ever?
No, sir.
These are the tests for the data normality.
Yes.
Any data, raw data I deal with, and I wanted to perform, right? Maybe the neural network is a assumption free, but once I perform the like the multiple regression for the purpose of equation, there is one of the assumption for any kind of the statistical test, the data has to follow normally, right? So
Yes.
Here I click the Sapir-Whorf test here. Okay. For the same data, I got this output. Now my p-value is the 0.03.
Less than 5. Less than 5.
So what is the interpretation, sir?
बोलो बच्चे लोग बोलो बोलो.
No, it is normally significant.
Statistics.
The statistically significant.
Now, So,
Data you want to
no,
take now.
so the basically out of this, what was my objective? Please understand. My
Okay.
objective, I wanted to
Is-
do a data normality check for a variable called height. For
It
your
is not.
case, it could be any raw data, right? I wanted to do a data normality check,
Okay.
right? So here I
In the
applied a
normal.
data normality test called Shapiro-Wilk test. I do
Okay.
have the similar type of the test also I may come across from the various research paper like Anderson-Darling test, Smirnov-Kolmorov test, and I got a output. My p-value is showing the 0.03. So
Okay.
I can conclude now I do have a statistical evidence to suggest that this variable called height does not follow a normal distribution.
Normal, because it's out of the yeah.
No, the p-value is the 0.03, which is less than p 0.05.
Yeah.
Okay. If my p-value would have more than 0.05, I would have concluded that data follows a normal distribution.
Ask him whatever the temperature average.
Fine. So this is the right. Once I do that, I will explore something. What typically you do. So what we now found that this variable called height, there are certain data points which are contributing to the non-normality, not the 100 data points, right? Out of these 100 data points, so which of the graph we typically use for your outlier detection, sir? Because my idea here, how I can explore the data visually, quickly. I did for the data normality check, I draw a histogram here, the graph one, right? And I draw a graph here and I applied because as I told, I went to the quick, then I went to the advanced. Under the advanced tab, I got the feature of the Shapiro-Wilk test, right? Smirnov-Kolmorov. So I applied the Shapiro-Wilk test for the data normality check. Now I wanted to visually explore on the basis of my findings that this variable height includes some of the data points which are contributing to the data non-normality. So which of the graph will help me in that? So for this, we have a very like commonly used graph called box and whisker plot. I went to box and whisker plot. I was dealing with the variable called height. Okay. And this is the basically the selection, right? I can do the changes on, we are going with the median. Let's construct the graph. What you can figure it out, sir, here?
Yeah.
In the right side, you see the narration of this graph. Median is 68. This is the median 25, 75, right? This is the 20 percentile of the data. This is the 75. This is the range of the data 66 to
70.
No, sorry, 61 to non-outlier range is the 61 to 75. The below is the 61, upper is the 75, right? And here I see this circle.
Two data.
Two outliers are there in this variable called height, which is contributing to the non-normality. Now my task is how to identify these two data points. We have a features called brushing. I go to the brushing, right? Under the brushing, I wanted to label this. You see, it has been labeled with the 60, #60, #72, right? So these the data points, these are the number of rows 60 and 70. Let's go and investigate. It has been labeled the 60 and 70. Sorry, 72, I can see the data point is the height is the 58. So it was away from the outlier range because the outlier range was the 61 to 75. So it was from the end in the 60, I see 57, right? So both these were the outlier range. So how to deal with the outliers, sir? How you deal with the outliers?
Just remove it.
Please remember, because all this data preparation, because I will show you this equation also, it is a click of a button. But unless until you have made your data ready for the analysis, right? So that is the reason the analyst or the researcher, they consume in between 70 to 80% of their time for the data preparation. Because suppose you take this garbage for any kind of the analysis, you won't get a good result. So you need to double sure before you're taking the data to the lab, the data has to be clean, the data has been properly analyzed, and these data are ready for analysis. That is the reason the analyst and the data scientist, they consume 70 to 80% of their time for data preparation. So I go to for all these data related activities, I can do through the tab called data, right? Recalculate, transform, rules builder, so and so forth, right? So we have the various transformation technique also, box transformation, filter, record, auto, and all this stuff. So now I wanted to record these outliers, filter and record these outliers, record outliers. I was dealing with the variable called height, right? Repeat until all outliers have been recorded. Even you can define your iteration also. There are variety of the tests are there to deal with these outliers. So one of the very, very popular outlier test is the Tucky two-sided. Here, there are variety of the treatments are available. Record outlier to no record, record outliers to missing data, record outlier to a value, record outlier to a mean, record outlier to mode, record outlier to percentile, record to boundary. So the best practices are the record to mean, right? Let's investigate. Now I'm at the 60 variable. Earlier it was 57. Now it has been recorded to the mean. Recorded to the mean, right? In addition to that, the Statistica also provides a very advanced feature. This is very specifically for the researcher. You can write any kind of the mathematical expression, the way you do with the Excel, you do with the other the software. You go to the under the data, you go to the transform. Let's assume we wanted to do a log transformation. I put the log transformation. We were dealing with the V4 variable 4, that is the height, or you can write the variable name also. You can put the variable 4 also, depending log V4. The following variables on the right side of the yes expression. OK, my expression has been OK, right? So I get this is the transform on the basis of the log transformation, right? Even if we wanted to do the box-Cox transformation also, I can do. Let me. Now, what is the interpretation, sir?
No, little better.
Yeah, so now I can claim because after I gave a treatment to only the two data points which were contributing to the non-normality, right? So after I gave a treatment to change these data points to the mean value, now my data has become normal, right? I get a p-value which is greater than 0.05. So I
Right.
can claim this, the data is normal. So this is the way we can do with the Statistica, right? Uh, Suppose I wanted to see, I do a hypothesis whether the height of the male and female, what would be the hypothesis, sir? Suppose I wanted to compare the height of the male and female. What would be my H naught or the normal hypothesis? For any of the research work you do, you need to construct a hypothesis, right?
Right, sir.
So suppose I'm doing a hypothesis. So what would be my null hypothesis? Here, I do have a situation in a click of a button. I wanted to determine whether the height of this gender, the male and female, the height. So what would be my hypothesis? The null hypothesis H naught, or you can say Ho, right? For the purpose of remembrance, what would be the null hypothesis?
Not better, but
Male is greater than female. Yeah.
height of the male is more than female.
No. For any of the null hypothesis, this is also known. It is basically abbreviated as the H naught, right?
H0,
Which is
not.
yeah, which is also known as the monk hypothesis or the boring hypothesis. For any of the hypothesis testing we carry out, ideally the null hypothesis, there is not a significant difference
Yeah.
between the height of male and the female, right? That would be the null hypothesis. There is no significant difference between the male and female. It could be anything, right? Suppose I will be doing a testing for only the male and female, right? So this will be a t-test. Suppose it will be, I'll be doing a test for like the gender, the color, right? The brown, black, it will be more than 3, then it will be ANOVA, analysis of variance.
Right.
But normally my hypothesis will remain same. My null hypothesis, alternate hypothesis, across the hypothesis testing, it will remain same because there is no significant difference, right? So let's do it, explore it visually. So for all these, like the t-test or for the mean calculation, we have a plot called mean plot. Mean plot. I have this height. I have the gender as grouping variable.
Confidence interval 99%. I know, but
Yeah. So basically, what you can say, but for this, what typically we do, we perform a t-test. Visually also, I can see there is not a significant difference, right? You see both the mean, the interaction mean plot.
Yeah.
There is not a significant, but suppose I wanted to support with a statistical evidence, we can draw a,
Line.
we can apply a t-test here. T-test independent by groups or something. Let me check out if I do a t-test, because what from the visually we could explore, there is not a significant difference between the height of male and height of the female, right? So we accept our null hypothesis, right? But suppose I wanted to perform through statistically, I go to the statistics, I go to the basic statistics, t-test independent by groups, t-test independent by groups, okay, variable, my grouping variable, this thing, height, okay. What is the p-value is showing, sir? You
7.5.
see, here you see the mean of male is 67 and mean of female is the 68, right? That not a much different. If the and the p-value is the 0.75, that is the reason the hypothesis testing is known as also the confirmatory data analysis.
Mm.
Because see, I could very well through visually through the mean error plot, I could see that there is not a significant difference height of the male and female. But here I am also confirming through statistically, because now I get a table where the p-value is greater than 0.05, right? So I can conclude there is not a significant difference between height of male and female. Getting me, sir?
Yes, sir. Yes, sir.
So this is the way we do the exploratory. Another some of the graphs are left where scatter plot. What is the purpose of the scatter plot, sir?
Really no. Is it relation interesting? Okay.
What is the purpose of the scatter plot? The purpose of the scatter plot is, suppose I wanted to do a study of, yes, sir.
How the data varies, sir, if I change linear or non-linear or some regression type of thing we just want to study. The change of x, how the variation of the y occurs. As we see y equal to mx plus c in case of the straight line or something. Or in case of the polynomial or regression analysis and also we see that from the data we can visualize.
So that we are taking, that we are talking about the equation, sir. But what is the purpose of a scatter plot? Like here we wanted to study like the data normality. That let me give you some hint. Suppose you wanted to do a data normality check, we draw a histogram.
Check and whether some
Right.
outliers are also there, whether the data is generation is a proper form, that the way we are doing it is going to the as per our hypothesis and all this. If many outliers are there, then we have to adjust the data or form in managing such a that we can make it normal.
The purpose of the scatter plot, suppose I wanted to study between the relationship between the two or more variable. Right?
Relationship, external.
Yeah, it's the relationship between the two or more variables. So let's assume, like, suppose I wanted to see the height and weight relationship. Let's see, study, is there any relationship between the height and the weight? Okay. Can you tell me, sir, is there any relationship?
No, sir.
Yeah, it's basically it's a negative relationship,
Negative,
right?
negative. It goes to the, yeah.
Yeah, it's a negative relationship, but I am seeing if I go to, as I was talking about this, right? So basically the relationship are measured on the basis of the R.
Hours.
As I told, whenever you are
Yes.
doing something, you do not get something, you need to explore to the advance, right? If I do the this R, this small r or the big R, that interprets the relationship. Here it is showing the minus, means there is a negative relationship between the height and the weight. If the weight increasing, the height is decreasing, kind of thing, right?
Yes.
And on the p-value, as because you can see, but the R square, this is the equation you are talking, sir. Y is equal to,
Coefficient of determination
yeah,
and correlation coefficient also are very poor here.
yeah, because this is the, this y is equal to a plus bx, y is equal to, this is the beta, sorry, this is the intercept, sorry, sir.
Yes.
Y is equal to, this is the intercept, this is the beta or the coefficient of determination, x denotes to your variable, right? That we'll be learn how we can get the equation, how we can deploy the equation, that we'll be learning in the second part of the session. But here is the idea how in the small through the visualization also you can explore the graph. Then we have something called variability plot. What is this? Like suppose I wanted to see the data variation. I wanted to see the data dispersion between the gender, the male and female. What is the interpretation here, sir? I draw a variability plot. The purpose of the study is to understand the data dispersion.
It's not uniform.
Yeah, out of this variability plot, I can visualize the data points are not widely spread or it is not dispersed. In compared the female, this data range are the more because the minimum and maximum are more. Also, the data is not tightly spread compared to the male. Right? It is ideally when, like, suppose you are receiving the data from the 3 different lab for the same purpose and you wanted to do a study like the lab A, lab B, lab C, whether the data you have collected is properly distributed or not. This is the graph you can apply. Then we have the line plot. This line plot is also known as the trend graph. Suppose any data which comes along with a timestamp. And we wanted to also understand
Too many outliers.
yeah. Right, so I'm pulling a data called series.g data set series.g. right? I wanted to draw a line graph to get a sense because this data set consists of the passengers traveling in an airlines from January 49 to 9 December 144 data points. This data point has been collected the monthly. The passengers are traveling in an airlines in thousands. One like 112 means this is a 112,000, right? So for this to understand the trend of this air passengers traveling and to get a sense of the seasonality, we draw a line graph. Line graph, series G, right? So, and again, what I was talking about, you can just right? You can have the full control over this graph. Whatever you wanted to do with this object of this graph, you can do so, right? So you have, right? So you can do all these challenges, means changes. Fine. Any observations are from this graph? Because there are two purposes for the line graph, or also known as the trend graph. One is to get a sense of the trend because see, it's in an increasing trend. In addition to that, we also wanted to find the seasonality from this graph. So any observation is there from this graph?
It is gradually increasing with respect to the time or months, the year.
Yeah.
Uh,
But suppose we wanted to have a see in the month of the September.
hmm.
Month of the September, basically the air passengers are the decreasing.
Yeah, right.
So you can get a off-season kind of thing, maybe like across these 12 years, month of the November, the air passengers are decreasing.
Decreasing.
So this kind of the seasonality also you can get a sense from this line graph.
Right.
So we have exceeded the time for the first session, sir, right? So again, we'll be meeting at 3 o'clock.
Right, sir.
3 to 5. So we'll be talking some part of these test and as suggested because deeply you have been working with this design of experiment and this optimization. I will show you typical some of the example for the optimization, doing both using the multiple regression as well as neural network, right?
Can we send some data so that after your class or during that day, can you help us to analyze this data?
The data all are there in the example data set, sir. Whatsoever I
Okay.
did so far, all are
Okay.
available in the example set. I have not gone outside of the Statistica so far.
Okay.
Apart from only one data set.
Right, sir. Then it will be fine. Fine, sir. Fine. So we are now we are.
Yeah, so by 3 o'clock, we'll be meeting again, sir. Thank you.
Sir, kindly save this video so that we will request you to take this video. Okay.
Yeah,
Without
yeah,
video,
yeah. I have
we have
recorded
to do a
this.
lot of practices, huh? Right, sir. Okay.
Right.
Yeah. Thank you, sir. Thank you.
Thank you.
We are meeting at 3 o'clock again.
Yeah.
Thank you. Thank you. Wait.